Hey everybody, Paul McKenzie here from the University of Ulster, School of Geography and Environmental Sciences. This is just a quick video to give an introduction to a renewable energy activity that we ran at Geotopics in 2024 and also given an overview of how that activity might build into future activities in schools, but also for Geotopics in 2025 and hopefully beyond in future years. So this topic, or this presentation, will just give an overview of what we're proposing and set the scene and outline some associated activities that we have that go along with this video. So the objectives for the sustainable energy or renewable energy activity that we're proposing are twofold. Really, the first idea is that we propose a fieldwork activity for use with Key Stage 3 pupils. And that activity would be based around renewable energy on school sites or school campuses. Secondly then, what we're trying to do is to demonstrate a range of mapping websites and applications that can be used freely via browsers or free using Esri Survey 123 or ArcGIS Online accounts. And those Esri accounts are totally free for schools to use in Northern Ireland and allow you significant capabilities for fairly simple mapping activities right up to more advanced mapping capabilities. So those two objectives really frame what we're trying to do through Geotopics this year. The context for this then is energy education. As we all know from the news and from our daily lives, that decarbonisation is a critically important issue. The move to net zero and the associated move away from fossil fuels to renewable energy technologies is vitally important, not only for ourselves as teachers and educators, but more importantly probably is for our young people who are going to go into sectors that are associated with green economy or blue economy or whatever, and trying to make living from that economy and that sector. But also, more importantly probably, is the idea of their literacy and their behaviours and their knowledge and their attitudes to all of these issues about moving away from oil and coal and moving towards green technology like wind or solar. So there's a very strong association here to energy justice and climate change and geopolitics, these really big issues that have an overarching effect really in geography, but also so many other sectors of our world. Energy justice is the idea that as we move away from fossil fuels like diesel cars and we move ahead to EVs or electric vehicles, that those policies that are in place don't impoverish groups of people, that they don't have an impact on people adversely, and that the transition to clean energy is fair and just for everybody in society and doesn't put any particular groups at risk. And we also have seen here most clearly through geopolitics that the war in Ukraine had massive impacts on our food prices, our electricity prices, our gas provision, and it led to a consistent narrative in the UK particularly that we were at risk of global politics that would jeopardise and increase our energy prices. And at that time it led to a view of trying to keep our energy production within the UK, and that inadvertently led to a boost towards the renewable sector. So all of these are really issues that link into both energy literacy and climate literacy, and these ideas of what students know, what they know is important, but actually what they do in terms of their behaviour and their beliefs are probably even more important. So all these things dovetail into this topic and try and get students to know more and to be more involved in thinking about renewable energy, but not only about the production of energy through renewables, but also through the reduction of their own energy use. That's often overlooked, but if we can actually reduce our energy use as well as producing cleaner energy, that's a double-edged sword, and it actually produces so many benefits. So it's awakening students in some ways to definite action that they can have that will not only help to save money through reduced energy use, but will also help to reduce carbon footprints and also help to produce energy for what we do need to use it for. And all these skills and attitudes are really, really topical within geography, but also across social sciences as well, in a whole range of different sectors. So as we propose this topic, there's a very strong potential for students to ask questions, for students to frame the learning according to how they see things. If you're a coastal school, you may look at tidal. If you're in an upland area, you may look at wind. If you're in a sunny site, if anywhere in Northern Ireland sunny, you may be looking at solar PV. So students can approach this in an active learning style. They can ask their own questions and try and then go out and find out how to do things and where to cite things and some of the problems that might be involved in that process. Also, it's a great opportunity for problem-based learning, for us to ask a question and ask students to try and tackle that question in a whole range of different ways. Really, I think the point for us is that there is no right answer. Certainly there are things for us to look at in terms of wind. Wind should be sited away from buildings. It should have a laminar flow. It should be sited according to the prevailing wind direction, etc., etc. But there are other options that are available, and really for us, what we're really keen to see is students thinking about a whole range of things and trying to bring all those things into their learning experience in this activity. So we've also tried to develop an activity that works on map work, field work, critical thought, sense of place, physical processes, interactions with human environments, and also sustainability. So just one example of that would be community energy, whereby we see groups of people perhaps owning a solar site or a wind turbine or a tidal resource, and they all contribute to that. They form a community that will then generate that renewable energy source, and then they also equally benefit from that renewable energy source, so they actually see a return on their investment. And this community energy source really is a beautiful example of how geography not only puts renewables that are tailored and targeted to specific sites where they perform well, but also the human aspect of that. So they're the people who set up these community energy sites. Their behaviours change, they think differently, but they also are invested in their local place and trying to think how their local environment could host different renewable energy sources, and also equally how they could gain from that in a monetary fashion. So this doesn't just involve geography, it's available in physics in the Key Stage 3 curriculum and also in science more generally. So just to give an overview of that, this is the science agenda on the BBC Biteside website, and it shows science, physics and conservation of energy. And we can look then as well at conservation in terms of wind turbine. As energy goes through kinetic, it produces energy that can be used in homes. And we can also then look at renewable sources of wind or solar or tidal or whatever. So renewable energy is very strongly in place in the science curriculum at Key Stage 3, but it shouldn't just sit there. It should obviously be part of geography or the environment or marine science or whatever we wish to look at. So we can bring in a whole range of factors looking at how much renewable energy contributed to Northern Ireland's energy use. And we can see here that wind's very, very dominantly 85% of renewable energy supply, but we're still really less than half of total electricity in Northern Ireland being generated from renewable resources. So there's considerable scope. And what we're also trying to do here is show things like geothermal. My colleague Rory Quinn has done an entire talk on geothermal energy and its potential to offset some of these energy uses in domestic buildings or industrial buildings or whatever. So we're really trying to look at equipping students with the knowledge to turn this 45% or 49% of renewable energy in Northern Ireland up to 50, 60, 70%, and really as far as we can possibly go. So to give you an idea, that's where the physics is looking at it. Also in science more generally, we're trying to get students to look at writing hypotheses. This is what we believe will happen if we do something. So it gives us an opportunity not only for only active learning, but as part of active learning to write hypotheses and make predictions and say we think that this will happen if this is done. And also what we can do then is look at different types of data. We can observe things, measure things, we can create graphs and charts, we can do all sorts of things that really give our students a very comprehensive overview of not just one subject, but how our subjects interlink and form partnerships really with other teachers to give our students a more holistic form of learning, which is valuable. So then if we look at our geography, we have an awful lot of capability with weather data. We can look at historic patterns, we can look at today, we can see how much rainfall is occurring in certain months. So the Met Office has given us a vast amount of data that could be used to look at how our climate and how our weather patterns are changing year on year, month by month, and making our students more aware of perhaps things like water shortages. So if we set up a water butt or a water harvesting system on our school campus, what impact does that have on reduced rainfall? We might not think about that in Northern Ireland, but it is really important for us to have a good behaviour and good attitudes towards clean water so that we can avoid problems in the future. And secondly, we can look at our coastlines and we can look at our rivers. So again, it's no accident that London is on a list of countries across the world, such as Cape Town and Sao Paulo, who are looking at dirty water and having a real problem about supplying clean drinking water in the future. So we can look at our rivers and we can look at how those rivers are behaving, not only in terms of flood, but more importantly, as we look at climate change, how our rivers are actually experiencing significant parts of drought in parts of the year. So we can look at our rivers flooding, we can look at our rivers drought, we can look at river flow in terms of housing nearby and impervious surfaces. But above all that, we can also look at rivers or coastlines in terms of tidal energy or hydroelectricity projects. So we might live near a significant river that has good flow for most of the year, and we can say let's set up a renewable energy project on that site so we can actually harvest some energy from that flow of healthy water along that river section. And just one example is Shane's Castle. Shane's Castle have a number of very small renewable energy projects on very small rivers going through the site, but these are excellent examples of how fairly low cost solutions can be deployed to actually produce renewable electricity. So it's getting students to look at things that we're looking at in a way in geography, but looking at it with a different lens. We're also looking then at energy supply, obviously, and energy resources, looking at this in terms of field work. How do we draw sketch maps? How do I use a compass? How do I actually draw a sketch map? How do I draw a map? What other skills do I need to actually navigate my landscape using ordnance survey maps? So all of these skills are inherent into this process and things that we want to try and demonstrate. And then also looking at rocks. So as I've mentioned already, Rory Quinn has kindly done a topic on geothermal energy, and he's looked at Munich, Southampton, and then he's also considered how our aquifers and our geology lend themselves to geothermal energy supply for Northern Ireland's sustainable future. So we can look at all these things as well, and ultimately it all comes down to map skills, atlas skills as well. So our students are getting excellent geography, but they're getting excellent geography and trying to think holistically and collaboratively with other subjects to try and be more rounded learners, and then going into our world with a better view and better attitudes and better knowledge, but also better behaviours that will be more sustainable in the future. So looking at my own son's geography book at the minute from Key Stage 3, it's quite incredible all the different things that we can look at and bring out. So we can look at things like making and mapping connections to where are solar panels actually manufactured. What's it like manufacturing solar panels in Germany or China? What's the carbon footprint of bringing it over here? So those things can be done through connection mapping. We can also look at things like plans and scales and maps and grid references and lengths and directions, ordnance survey maps. Everything is possible using Spatial NI and other freely available websites. So that's sort of one of our main objectives, is to try and show these websites and how they tie into our Key Stage 3 curriculum. We can also look at roofs, We can look at open sites, we can measure things, we can do whatever we need to do. We'll also be using aerial photographs, ordnance survey maps, and looking at 4- and 6-figure grid references as well. We can see sustainable settlements, building design, or climate, hydroelectricity, geothermal. All these things are possible and highly linked to the Key Stage 3 curriculum that our students are going through. So in chatting to some teachers, Mark Stevenson of Strathern and Andrew Blakely at Cambridge House, they were both really helpful in trying to guide a lot of the thinking around a fieldwork activity. And most teachers were saying, we'd love to do fieldwork, but really the reality is that we have to take students out on school sites or to sites that are walkable nearby. So Colin Breen and myself thought a lot about this, and we both agreed that the school grounds or the school campus would be excellent, because it doesn't matter if you've got a very large rural site or a very tight footprint in an urban area. Every school has the availability of some renewable electricity, and we don't know every school site, but you do, and your pupils do. So it can be a way for you to actually analyse and scrutinise your own school and how that school could be updated, equipped with different forms of renewable electricity that would offset some of your electricity use. But also, remember what I said a few minutes ago, it's not just about offsetting your energy through renewables, it's also about how you cut down the energy use that's already there. So it might be simple things like turning off lights whenever you're not in a room. It might be shutting down computers when they're not in use. It might be a whole range of things. It might even link into active travel. So this is an opportunity for you to really scrutinise and look at your own school site and how that site might become more sustainable in the future. We also have tried to propose something that could be done with really 100 students plus, so it doesn't really matter. And we've also tried to look at this in terms of a short amount of time. So I will demonstrate a couple of practicals at the very end of this video, and all those practicals are broken into individual exercises. So you can pick up things, you can build things together. It's designed like the Lego model, where you can just take one bit at a time, or you can connect bits together to make a bigger model or a bigger piece of work. It also ties into other people that are out there, like eco schools. We can tie in with our communities more effectively, and it also hopefully will give us, at University of Ulster, an opportunity to perhaps run a competition in a year or two's time for schools to enter a competition and say, here is our school's sustainable energy plan, and you can put in maps, you can put in proposals or data or things that have been measured, and that would hopefully be judged for prizes then at Ulster, probably most likely in 2026 or maybe even in subsequent years. We're also aware that this has to build up for other parts of the curriculum. So it does tie into Unit 2, probably more so in terms of managing your environment, looking at renewable energy, solar and wind, and advantages and disadvantages of those forms of energy. And we can also see here that it does tie into weather and climate. However, that probably ties in a little bit more into wind direction and wind speed. Precipitation and temperature are possible. The Met Office provide that data, but it's something that we haven't really touched on for this year, though it is possible for future years. And then obviously it ties into A2 for sustainable settlements as well. So the proposal is then to look at every individual school site according to your own school. So if you're from Ballyclare, you'd look at your own school site in Ballyclare. If you're from St Pius, you'd look at your own school site in light of that as well. So these are giving you different opportunities for different schools, and it's totally tailored to your own students and your own school grounds, so you don't actually need to go anywhere apart from out the classroom door. The focus is really on solar PV and wind, but there is no impediment or barrier for you to try and consider other options that might be available for your school. So for instance, if you were near an industrial production plant in Belfast or Derry, Londonderry, you can then look at that site and say, our site might benefit from district heating. Or you might also say, well, we're very near Stormont or near Caffrey, so geothermal might be a potential for us. or we're a coastal site, so we might use tidal, or whatever it comes to mention. So there is no right answer, there is no wrong answer. If your pupils are really engaged and they want to propose an anaerobic digester, that's absolutely fine. We're really excited by that. But if they are doing that, they need to make a strong rationale for that and why they've chosen that. So if they're from an agricultural area and they have experience of anaerobic digesters and they think that would be really, really useful for not only their school but for their local community, then certainly that would be something that would be really exciting to see. So overall, our plan is that we learn and develop this renewable energy activity hand in hand with teachers, with yourselves, and then probably do a review in June 2025. And in June 2025 we would hopefully have some volunteer teachers coming back and saying, listen, we ran this activity with our students. These things worked really well, these things didn't work well, and we tried this as a result, and here's a good solution. So what we think is that this will be a review exercise in 2025 for teachers who are really interested. We would then record those talks and then hopefully run a competition that's crafted in collaboration with teachers and schools for a runoff in 2026. So this really begins the process, but it is very much an aim for a learning partnership. We're trying to learn lessons together, so it's not a case of us telling you specifically what to do. It's a case of us floating an idea and trying to give you simple skills that may be useful for you as you develop this, but we recognise that teachers are the experts on what you need to do, what's feasible to do, but so we need to learn from that as well. So the proposal then, we've a whole range of fully illustrated practicals. I've written maybe 4 or 5 practicals on Special NI, Shade Map, PV Watts, Wind Finder, and Survey 123. I focus on the Korean campus generally, Ulster, but obviously you would substitute that with your own school site and change it to your own requirements. I've divided the practicals into short exercises that you can take on their own, but they also obviously build up into each other. So if you went through everything, it gives you an idea of how they can build up and give you an overview of an activity. All practicals are free. They're entirely accessible. I have made the practicals available as Word documents so that you can download them, print them, edit them, change them, whatever you wish to do. So they're designed to be open source practicals that are that can be tailored or tinkered with according to your own requirements. So feel free to use them, but they can also be accessed from school or home. So if you decide to get your pupils to do something at home, that's absolutely fine. All they need is an internet connection and a browser, and these technologies will work. The practicals also demonstrate how to create a short survey with Esri 123, so you can collect data in the field. And as I say, there's no impediment to thinking about other renewable energy sources that could be used. The sky's the limit, really. So just to give a really quick overview, solar PV is generally seen as a rooftop thing. That's okay. Generally the literature says that greater acceptance of solar PV is for solar on roofs or also on walls or on buildings. So I want you to try and think about that. So it might be tiles that are on the roof, it might be panels that are wall mounted, it might be covering a car park and putting solar PV on the roof, it might be covering bike sheds with solar PV. It doesn't matter. But really the idea is that you can think about solar PV on grassy sites, setting up an array in a field or a garden, so that they're generating electricity away from a building. They can be on a roof, or they can be on a wall, or they can be really anywhere that you think is feasible. The two important things for solar PV are that it faces generally a southern direction, though they can be east or west to capture morning or evening light. Also, they need to be fairly unobstructed from surrounding features. There are other impediments in terms of grid connection or electricity connection, but generally speaking, that wouldn't be something that we would worry about just so much. So building integrated PV is really important. You can also think about wind turbines. So this is a very flamboyant example. So right over here, it's not particularly good, simply because the wind flow is more turbulent and less laminar. It's not producing highly effective wind, it's probably drawing attention to the building more effectively. But if your students want to propose something like this, we understand the school's not going to pay for it out of the school budget, but it gives you an idea as to where some turbines could be located. On the left, these are turbines that are sitting at the edge of a roof at Logan Airport in Boston. So as the wind hits the building, it goes up in an updraft, and that updraft is often better captured with turbines that are located at the top of the building. So again, it's getting your students to think about some of these things and propose where turbines should possibly be located on the school grounds. Some of the other things that I really like are the miniaturization of turbines. On the left here, these are turbines that are fairly cheap in terms of wind turbine technology. They generate electricity, but the lovely thing is that these are actually capturing the flow of vehicles as vehicles drive past. So for instance, on a motorway or a busy road, these turbines are turned as vehicles go past. So they're generating electricity as a byproduct of something that's already happening. Also here we've got a very small turbine generating electricity, and some of the ones that you might see on fields and agricultural locations as well. Wind just doesn't have to be a turbine. It can be something like a cleverly designed roof, which works on the Venturi effect, where you've got high pressure and low pressure, and it produces very strong airflow as a result of different pressure systems. So that might also tie in to how buildings are actually designed. So this is a very interesting article that's linked down at the bottom here. So if a building is a big flat face and it's facing towards the prevailing wind direction, that flat face can then create updraft and downdraft, and downdraft has a significant problem in London. It can actually turn over vehicles. It's led to some deaths simply because the wind hits the big flat face of the building, and the wind then either goes up or down, and it can have very, very strong gusts as a result. So you can read more about that here. And it's talking then about building design, urban design, and a whole range of different things. So that's really very interesting indeed, and you can read more about that as you wish. I've also given you a link here to the Siemens building in Masdar, which has been cleverly designed with these fins along the front of the building. They're all orientated towards the prevailing wind direction from the northwest. So the wind comes in, goes in through the fins, goes through the building, as you can see the red arrows, and actually provides a natural cooling effect on the building so that the extreme temperatures around that area are offset to some extent without expensive energy use for air conditioning. This is based on a very, very old Arab system called a barajil, or a wind tower, which have been around for hundreds of years. And basically this is just a redesign of that original concept, but a way also of not requiring energy and reducing costs and leading to a lighter footprint. So that's a really quick overview of what we're trying to do. Rory has provided a full lecture that's linked in this talk here on geothermal energy. I've also given you a presentation or Word documents on Spatial NI, Survey 123 from Esri, and on Shade Map, PV Watts and Wind Finder. So if you click on any of those links, it'll take you straight to the resource, and within those resources I've got fully illustrated practicals with screenshots, clear simple instructions, but also I've provided video steps of each step so that a student or a teacher can watch that video and work out exactly what I'm doing or how to make it work. There's also additional resources here, and I'm just going to break out the PowerPoint now and show some of those additional materials. So our school website here has geotopics. So if you just Google ulsteruniteges.com, you can see all of the geotopics material on this link. And these are the talks that we've built up over the course of the last 5 years or so. So you can click on any of those talks or links. Rory's talk is linked here, and his presentation is available for download with links and resources built in, and then my own stuff will be linked under this video, and if you click on any of these links here, it will then go off and give you a full practical, and I'll just demonstrate that really fast so you can see what I mean. Okay, so again, Word document, so you can edit them to suit. Full URLs, full screenshots, nice and simple, step-by-step instructions of grid squares, finding locations, how we do some mapping using 6-figure grid references, and then, as I say, I've also embedded videos of every step that I've done, so those can be watched. If something is unclear, that video should make it much more clear as well. And then something that I didn't get a chance to do at all was Wind Finder. So again, you can click on the Wind Finder video, and once it loads, you can go through a free website called Wind Finder that looks at prevailing wind directions, and how we use protractors to look at different angles. So again, tying on a little bit to maths, and then looking at different runways, and also then looking at Abu Dhabi and looking at that Siemens building and how it's been designed to make use of the prevailing wind direction. So those videos and pages are all there, all totally accessible and available for you to use. But we appreciate feedback, so if you find it useful or you think things could be improved, please tell us, and we'll be delighted to hear from you. So sincere thanks for everything and all your support. We recognise that without teachers we couldn't really do anything that we're trying to do. So if there's anything else that we can do to help, please let us know, and we'll be delighted to help. So thank you very much indeed, and we'll see you in 2025, all being well. Thank you.